Hello everyone. If you would, please turn to page 6 in your notes packet. We're going to turn to the page that says Phase Change Diagram at the top. So page 6 in your notes. So while you're getting that out, I have good news for you today. We're only going to complete one page in the notes today. So if you hang with me through this, that'll be it for the notes for today. So hopefully you have that pulled out. We're now at page 6. It says Phase Change Diagram at the top, or affectionately called the butt diagram. And we call it that because, as you can see from the graph, it has 3 lines. So one that comes here, and then one here, and one here. And they all intersect here at this one point here in the center. And so because of the shape of the graph, that's why we affectionately came up with the name butt diagram. So to help you remember that. Well, the important thing about this graph is it actually shows you temperature versus pressure for any substance. So what this graph tells you is if you know the temperature and the pressure that a substance is at, you can look up on the phase diagram and say, at that specific temperature and at that specific pressure, what will be the phase of that substance? So if we were to look at, let's say we're at minus 78.5 degrees Celsius. So we'd go over to minus 78.5 degrees Celsius. And then it says, what if we're at 1 atmosphere? We would be right on this line. So what these lines do is they separate the 3 phases of a substance. So over here to the left is going to be your solid. Over here to the right, so this area outside of the butt, is a gas. And then the area up here in the top between these 2 sections of lines is a liquid phase. So if we were to look up at a specific temperature and pressure, so let's say we're at minus 78.5 degrees, so we're right here, and we go up to 5.1 atmospheres. So we would be at a point right here on our phase diagram. And what that tells us is this is right in the middle of the solid section of that phase diagram. So at a temperature of minus 78.5 and a pressure of 5.1 atmospheres, we would be right about here, and you would have, your substance would be a solid. So let's see what happens, like these lines here. So this line right here separates solid and gas phase. This line right here separates the solid from the liquid phase. And this line right here separates the liquid from the gas phase. So we can actually label our phase changes that we already know. So let's start with one of the easier ones. So let's start with a solid. So let's say we have a solid and we go from a solid to a liquid. We would call that phase change melting. So please write that in your notes above that arrow. So if you're going from this section of the graph straight over at that same pressure, but if you raise that temperature, you're going to melt that substance and it's going to go from a solid to a liquid. Well, we could go in reverse. Well, what if we started with a liquid and went backwards and cooled that down until it became a solid? Well, we call that freezing. So write that down in your notes. So let's look at the other phase changes. Let's say we have a liquid and we heat it up until it becomes a gas. You would then, if you cross from the liquid section over to the right side of this line, you'd be in the gas area of the graph. And so that phase change is called vaporization. And then if we had a gas and we cooled it down to a liquid, we would have to, we can label that phase change as a condensation. And let's look down here. So if we had a solid substance and it went straight to the gas phase, like what happens with CO2 when we take it out, the dry ice. This would be called sublimation. And then if, let's say we do the reverse. Let's say we start as a gas and we cool it all the way down until it becomes a solid, and we cross this line going in that direction. That would be called a deposition. So we have all 6 of our phase changes listed on this one graph. So what we can do is we can look at this graph, we can tell at any temperature and any pressure what is the phase of that substance is going to be. So what if we were at a temperature of 31 degrees Celsius but only 1 atmosphere? So I go over to 31 degrees Celsius and I go up to 1 atmosphere, and where they meet is right here. That is definitely in the gas section of the phase diagram. So at that temperature, at 31 degrees, and at that pressure, you would be in the gas phase, or your substance would be in the gas phase. Now there's 2 other points here on the graph that I need to make sure that I talk about. The first is right here, called the critical point. So the critical point is right up here at the top, and it's labeled with a C. At this point, so if you're, let me go back a bit. So if you're anywhere on the line, so let's say you're at a temperature of minus 78.5 and 1 atmosphere, you would be right here on the line for that phase diagram. What that means is the solid and the gas would be existing at the same time. You would be going from a solid to a gas. So here at this point, you would have both of them together. So it wouldn't all be gone, all of the solid wouldn't be gone, and it wouldn't all be turned to gas. You'd have both existing at the same time. Same thing up here. Let's say we are at this point on the phase diagram. It's definitely between solid and liquid phase, so that means it is melting. But that would be, at this point right here, it would be like you have a block of ice that is melting and it's sitting in a pool of water. So this would be the ice and this would be the water. It's in the process of melting, so you would be right on the line, right there on that phase diagram. So if you're on the line, you have both of those substances existing at the same time at that phase change. So let's look at the critical point, which is listed here, and then the triple point, which is right here in the center. So the triple point is really interesting. Right here in the very center, at the center of the butt diagram, you have all 3 phases coming together. So this is a very special point where all 3 phases can coexist at the same time. So you have a substance that is a solid and a liquid and a gas all at the same time. So you'd have a container. You'd have some solid in there, you'd have some liquid in there, and then you'd have the gas in there at the same time. So this means you have all 3 that coexist together. All 3 phases coexist, and that's at the triple point. And what other point I want to mention is this critical point, which is up here. It says it is the point at which 2 of the phases, or 2 phases of the substances, you can't tell the difference between them. So those 2 phases are liquid and gas. So when you pass the critical point, so notice how this line just ends very abruptly. So what happens is you reach an area up here to the upper right of that critical point. It's called a supercritical fluid. It's really interesting when you reach this past this point, because it acts not just as a liquid and not just as a gas. So it looks kind of like this haze, and you can't tell the difference between a liquid and a gas. It's kind of this wild, cool thing that happens whenever you reach really high temperatures and really high pressures. You end up getting a supercritical fluid where liquid and gas becomes indistinguishable from one another. So let's look here at the examples in the bottom. Let's use the phase diagram to be able to answer the types of questions that you could be asked regarding this. So we're going to pull down here, and it says number 1. What state of matter is this substance at 2 atmospheres of pressure and 31 degrees Celsius? So let's scoot back up to our phase diagram. If we are at 2 atmospheres of pressure, we're going to be somewhere right in this section here. And we're at 31 degrees Celsius, so we go over to that temperature and that pressure, we're right here. You would be in the gas phase, so right here. So I'm going to pull this down, and we'll write in our notes that you would be in the gas phase. So now number 2. It says, what happens to this substance if the temperature is increased from minus 78 degrees Celsius up to 0 degrees Celsius at a constant pressure of 72.9? So I'm changing the temperature, but the pressure is staying the same. So let's go back up to our graph, to our phase diagram, and we say, okay, let's first look at 72.9 atmospheres. So you can see here that pressure already has a dotted line listed on the graph. So it says, what if you start at minus 78 degrees? So you start minus 78 degrees, you're starting right here. So you start out clearly in the solid phase. But if you keep that pressure the same and you increase the temperature, you're going to go straight across this way until you reach a temperature of about 0 degrees Celsius. So 0 degrees Celsius is somewhere between minus 56 and 31. So you're going to be somewhere in this area. And in here, you are now in the liquid phase. So you've gone from the solid phase over to the liquid phase. So let's pull down here and let's write in our answer. So what happens to this substance? It melts. It goes from the solid phase to the liquid phase. So make sure you write that down in your notes. So now number 3, at what temperature and pressure is the triple point for this substance? Well, the triple point, remember, is where all 3 of those substances can coexist. So you look right at the point on the diagram where all 3 lines come together. This point right here is the triple point. So that is at a pressure of 5.1 atmospheres and a temperature of negative 56.7 degrees Celsius. So we're going to go down. We'll fill in our answer. We'll say 5.1 atmospheres and negative 56.7 degrees Celsius. So at this pressure and this temperature is where the triple point occurs, where all 3 substances coexist. And then lastly, at what pressure does this substance sublimate at negative 78.5 degrees Celsius? So you've got to think back and say, sublimation, that's where you go from a solid straight to a gas. And you're at negative 78.5 degrees Celsius. So it looks like you're keeping that temperature the same, but you're changing the pressure. So we're seeing at what pressure does it become solid to gas. So let's look up on our graph. First, we want to look at that temperature. So it says minus 78.5 degrees. So we go up, and on the line is where you have the phase change. So you go from solid straight to gas. Right on that line, you have sublimation. So where it intersects is at a pressure of 1 atmosphere. So it goes straight from solid to gas at this temperature at a pressure of 1 atmosphere. So I'm going to write this down in the bottom. 1 atmosphere of pressure is when it goes straight from solid to gas at minus 78.5 degrees Celsius. So that's it for phase diagrams. You should have everything you need to know in order to be able to work problems and answer problems just like these for your homework tonight.